In this video, we will create and run a Java MapReduce job that is identical in function to the Pentaho MapReduce job we created in the previous video. This will demonstrate the effort and knowledge required to produce a Java MapReduce job of relative modest complexity compared to the ease of visual development provided by Pentaho. To refresh our memory, the MapReduce logic involved counting entry page views by section of our website and emitting a file that looks like this. Records have been pipe delimited. The first field in the record is the category field as defined by marketing. We had to look that category up based on the section, which is in the second field. And then the last field is the count of page views, which are entry page views. Let me show you the program that we used to develop this in Pentaho. Here's the mapper, right, where we received the key value. We had to split the value into its constituent parts. We then filtered to only grab those records that were entry records based on the refer being a dash. We then split the URI record, the page being requested, in order to get the section field out of that page. We then did a lookup. We gathered section category information from an HDFS file, and we matched on the section and added the category to our stream. We then created our new key and value, the key being the category pipe section, the value being a 1, which we were going to sum up in the reducer. The reducer then, as I just said, takes the key value coming in, groups on the key, and sums the values, and emits a new record, which is going to be the key, this category pipe section, and adds a pipe and then the value. Our master job, our control job, then basically set up the job where we suppressed the reducer key outputs. All we got was the value, the actual record, and dumped that file out to the weblog entries folder. Okay, so let's get started coding this in Java. Okay, so let's open up the Eclipse IDE to begin coding in Java. We're going to start by creating a new project. It's going to be, I've loaded the MapReduce plugin for Eclipse to make life a little bit easier for ourselves. This will be a MapReduce project, and we'll call the project demo. Sure. Okay, so we are now have an empty canvas here. Let's create a new driver class. We'll put this in a package called demo, and we'll give the driver class the class name of my driver. The class is going to implement the tool. We want to use tool runner, so we'll look for tool here and give it a second to find the tool classes. Here we go. We want to use the Hadoop tool implementation, so it's okay. And we'll call our mapper. We'll give it the myMapper class, and we'll give the class name for reducer be myReducer. All right, looks like everything is good. Finish. All right, so it automatically generates the mydriver.java, and you can see it's already imported various things for us and created a main method, and that's it. So next on the hit list, then we want to use tool runner, so we actually want to use a run method in addition to the main method. So in that regard, I have to create the run method. So we'll go ahead and do that. Public. All right, and the run method is going to return an int run, and it takes with it a array of strings, so we'll call it args, and it will probably, I think we're going to have to do a throws exception to make this work. All right, so now we are ready to code our run method. The main method code here is really going to be done in the run, so let's just go ahead and grab all this code and cut it out of the main, and we'll throw it into the run method. Let's go finish up our main method here. Main is basically going to call run, so what we're going to do here is we're going to have to define a return status flag of an integer. So int, and we'll say tool runner dot run, and we're going to run a new instance of my driver, the class I'm writing, and we have to pass along with that the args. That's good. And then we want to do a system.exit with the status. All right, so that should handle the main class. Now I get a little error here. I think I need to include. I got to throw a declaration here, so we got to throw the exception. All right, good. All right, let's. So that finishes up our main method. Now let's go and mess around with the run method. We are going to need to specify the output keys. Now, basically the output keys are going to be a null writable for because we're going to suppress the key, and the output value is going to be a text. Okay. We are also going to need to specify. We want to specify our mapper outputs keys and values. So we'll do that. Conf set map. Oops, map. Let's see here. Map output key class, and the output class for the mapper is going to be a text. And let's set our map output class value class, and the mapper value class is going to be an int writable. If you remember correctly, we are passing out the category pipe section from the mapper as the key, and the value is just the number 1. Oh, I got a typo here. And our output of our entire MapReduce program is going to be a suppressed key, and the value is going to be the category pipe section pipe count of the instances. All right, I need to put a semicolon here. All right, now I've got some questions here. I probably have to include some things. Now I need to import the null writable. Yeah, need to do that. And oops, I got to put a dot here. That's why there's an error there. All right, so am I all set? Yes, I am. Okay, great. Now we need to specify our input and output directories. These are going to come as the first and second arguments from our command line. This is, since we're using Tool Runner, we've got to change the syntax around a little bit. So we're going to say text input format, set input paths, and the argument that's going to come in here is actually going to be args from our first our input parameter 0. So it's the first argument from the command line, and then we need to include in this call, we need to include the conf object, or job configuration object. All right, I think that's right. And then down here we need to do our text output format dot set output path, and again we need to include our job configuration, and the output path is going to be our second input argument for this method. Okay, now let's see what the Eclipse is telling us. Oh yes, we need to import text input format, and we need to import text output format. Thankfully I got these little help things here. All right, next we need to define our mapper and reducers. So we've do this here, but notice I've got an error because I don't have the mapper class defined yet. So we'll click on this and we'll say, yeah, go ahead and create the mapper class, just a shell of it. The package, we'll leave it in the demo package. The mapper is actually not going to inherit from object, but rather is going to inherit from MapReduce base. So let's browse for that. MapReduce, there it is. Grab that, and then we want to implement the mapper interface. So we'll add, we can cut and paste here, mapper, and it's this interface there. Great. All right, good. I think everything else should be okay. Yep, finish. All right, and we'll come back to the mapper code here in a second. Let's go back to our driver, and we need to deal with the reducer now. So let's see. Let's create my reducer class. Same thing. It's going to be MapReduce base. That, so that's great. And then we want to add the implementation for reducer, and there it is. Great. I think everything looks good there. Finish, and we'll come back to our reducer code here in a second. All right, back to our driver now. Oh, we have another little flag here. What's going on here? Oh, we got to configure the build path. That's odd. Okay, we'll have to sort through that here in a second. Next, we have to deal with a distributed cache. So we are going to grab the section lookup file from HDFS and throw it into the distributed cache so it can be pushed to each map task via the Hadoop engine. So I'm going to write some code for that. So we'll put a little comment here. Load the lookup file into the dist cache. All right, so we'll go distributed cache dot add cache file, and let's see here. We're going to go a new path. We got to create a path object, and we'll hard code the path for the purposes of our demo here. So this is the HDFS path of that file. Sections/sections.txt. All right, and then we need to convert that to a URI. RI. And then we need to add our job configuration parameter, and then finally finish this up with a semicolon. Did I get this right? We'll find out here. We need to import dist cache, and good, I got the syntax correct there. All right, let's see. Do we need to do anything else? We've got our job configuration, we've got our distributed cache, we're setting up our output key and class, and our value output value and key classes. We're setting up our map output key and classes. Let's see, what else do we need to do? All right, we're going to finish up here. We're going to have to run the job. I think everything looks good, and I will stop here now before we move on to the mapper. Well, actually, we've got a couple of problems here in the driver class. Let's solve these first. First of all, I need to return a status code for my run method. So let's go down and take care of that. A status of 0 means everything's successful, so we'll default that to 0. And of course, if I have an error, then I'll say status is equal to 1, and then let's just return the status then. So that'll handle that, I believe. Yeah, good, that goes away. And then there are a couple of unimplemented methods we need to add, so we'll go ahead and add those. These have to do with some configuration things. We don't need to mess with those. This will work without those. And we've got two imports here that are unnecessary, so we can just remove these to clean up our code a little bit. All right, let's save this, and I'm still getting an error. All right, so what's going on here now? It doesn't know my path, so you know what? I'm just going to hard code this in the package in here. Demo dot, and that should solve it. Demo dot, and that should solve that. So let's go ahead and save it again. And okay, so no errors now, so I can move on to the mapper. Okay, let's move on to the mapper. First thing is we have to define the key value, the data types of the key values coming in, and the data types of the key values that are going to be emitted. So coming in, we're going to basically have a long writable as the key. It's basically the byte offset of the record, and the value is the text. It's a line of text from our parsed weblog data. And we're going to emit text. That's going to be the category pipe section. And we'll emit the int writable, which is going to be the number 1. So now we've immediately got problems here, right? So we've got to add in unimplemented methods. We need to add the map method, of course. That's helpful. And it even gets our data types right. So let's go ahead and fix the signature on that. I'm going to call the first one argument key. The next one's going to be values. It makes life easy for us inside. The output collector, we'll just call that output. And reporter, we're not going to use reporter in this example, but I'll just rename it anyways, just for sake of doing that. We need to now check on some imports here. We need to import the text class. We need to import the writable class. And we're probably going to have to import the long writable class, yeah. Okay, so all of our imports are in. Now, since we are going to use the distributed cache, we have to take advantage of that by using the configure method. The configure method is run before any of the map methods are executed on all the rows flowing through here. So let's create that configure method. Public void configure. Oops. And this receives a job configuration object. And all right, so There's the shell of that. We are going to build a hash map of key value pairs, being the section as the key and the category as a value. We'll use that to look up the category for each section in our map that flows through on our mapper. So I need to create a instance variable for that. So I'll create a private variable, a hash map, and it's going to be of type string. We're going to be basically mapping strings to strings. All right. And we'll call this variable section map, and we'll just initialize it to an empty hash map here. Again, we need to make sure we do this right. String, the signature string, and I think that does that. Now, to save some memory and garbage collection, I'm going to create two instance variables to hold our output key and value for each execution of the map method. So we'll create our out key is going to be a text object. All right, so we'll just initialize that to an empty text object. And then our output value is always going to be the number 1. So so we can basically make this a final static variable. It's an int writable type, and we'll call it 1. And we'll give it a new int writable 1. All right, that should handle that. So let's go back to now our configure method and build the hash map object. All right, so I know I'm going to have to catch a couple exceptions here, so let's put a try block right at the beginning here. We now need to go, and we'll deal with that in a little bit, but we're first going to get a list of paths out of our distributed cache. And so we'll call these paths, and distributed cache dot get local. And these are HDFS paths that are going to be coming out. We only have one coming out, but we still have to get the array because that's how it works. So path, and we'll call this thing our cache path equals paths sub 0. Right? All right, so that gets us our, that'll be the path to our section text file, which we specified in our distributed cache in the driver. All right, next we want to now read lines out of that file. We're going to read a line of text out of that file. Each line is going to contain a tab delimited. The first field is going to be the section. The second field is going to be the category. And we're going to load that section and category into our section map, our hash map. All right, so let's create a buffered reader. Reader and new buffered reader, and that's going to get from a file reader. And the file reader then is going to have our cache path, and we got to convert that to a string. All right, that'll do it. All right, so that creates our reader. Next, we're going to have to create some variables here to save some memory. So we'll create a line variable. So that the new to null, I mean, and we'll create a fields, an array. String array, which will contain our fields that we parse out of our line. And again, we'll set that equal to null. All right, now let's start looping through the records, the lines in our buffered reader. So we're going to go get the line from our reader dot read line. All right, and when that is not equal to null, we continue. All right, so if we read a line that's null, we get out of the loop. All right, so while we're inside the loop, we need to basically parse the line by doing a split. So the fields will be equal to the line dot split, and the split now needs a regular expression in here. So these are tab delimited, so /t, and oops, I did not get the t. Let's see, t. All right. Let's see if I got that right. Line.split, yeah, tab delimited, great. Next then we want to add to our section map the key value pair. So we'll put fields, the first field as the key, and oops, the second field as the value. And I believe that will take care of our section map. All right, now we need to put our catch logic in. There's two exceptions we might have to catch. The first is a file not found exception. And if we do that, we'll just do a print stack trace here. P. Come on, there we go. Print stack trace, great. And then the next catch will be an IO exception. And we'll do the same thing. Cut and paste here to make life easy. Alright, so let's deal with some of these errors we're getting. I suspect we have to import some classes. Yep, import hash map. Let's see here. We need to import job configuration. We probably have to import the paths. Whoops, hang on a second. I think we want to import a different path than that. I grabbed the wrong one. Oh, that one's okay. I'm sorry. We also have to import distributed cache. We have to import Bufferedreader. I like to do these one by one just to make sure I get the right class. I know you can hit Control-Shift-O and it will grab them, but sometimes there's conflicts. I want to make sure I get the right one. All right, so that is how we code the configure. Now we need to drop down and code our map. So for our map, we want to parse the value, or the text that's coming in, right? So the line of text. So the first thing we're going to do is we're going to create a string array, and we'll call this fields again. And we'll take the value and we'll split it. And again, it's got to be a regular expression, and we're using a pipe to delimit our files. Pipe is a character needs to be escaped in regex, and we have to escape the escape character in Java, so we have to do escape pipe to be able to do that. And so now we need to pull out the URI, which is the page that's being asked for, and the refer. We're going to need the refer so we can filter and only get entry pages, and we're going to need the URI so we can parse it to get the section out. So let's do that then. String URI equals, and this is going to be fields, and I happen to know that it's the third field, which would be index 2, and string refer fields, and the refer happens to be in the fourth field, which is index 3. All right, next we now need to put an if loop in here, so we'll go if the refer equals, and we know that if it's a dash, it's an entry page. All right, so if that happens, we go ahead and we're gonna process, and we'll end up emitting a key value pair. So again, we need to split the URI. So let's create an array here. So this is going to be URI fields, and we'll do URI.split. And again, it's a regular expression this time. It's a /, and that's not a special character in regex. And we happen to know that the second part is the section. So section equals URI fields sub1. There's probably a more efficient way to do this. I think we'll be creating and destroying a lot of objects, but for the small data set, I'm not going to get too hyped up about optimization at the moment. Now we need to build our output key. Oops, out key is lowercase, out key dot set, and so we're going to create basically a string, which is going to be the section. We have to get the category from the section map, so we'll go section map dot get, and the key that we need to put in there is a section. Okay. And we're going to concatenate that with a pipe, and then concatenate that with the actual section. All right, so our key coming out that we're going to emit is going to be the category pipe section. And then the value is going to be the number 1, which you already defined as a static, so we can just do a output, which was our output collector dot collect, and we can put in for the key will be out key, and the value will be 1. All right, so let's see what we got going on here. We got an error here. What's the error? Right, I have the output, the text is value. What's going on here? Add casted value. Oh, I have to do a value. I have to turn it into a string. To string. Real-time programming here. All right, so that should work. Okay, so now our mapper compiled. I can save that, and I don't have any errors in my mapper anymore. So let's move on to the reducer. All right, so we have the shell of the reducer class. We need to specify the in key and out key, and the in value and the out value. Remember, the in key value pair is going to be a string and an int writable, right? It's going to, or a string. I'm sorry, it's going to be a text and an int writable. The text being the writable. The text being the category pipe section. And then the output, we want to suppress the key, so we'll have a null writable. And the value is going to be a line of text. All right. Now we need to deal with our importing our classes in writable and text, and probably null writable as well. Oops. Oh no, we got to add a. We have to add our reduce method now. Right. All right. So. Good to go there. I don't think we got the null writable, did we? We didn't. Let's see what's going on here. Here we go. All right. Now we're set. All right, so now we need to mess with our reduce method. Well, first I'm going to create two instance variables here to be more efficient with my memory. One's going to be our key, the other one's going to be our value. That's going to be generated on the output. So we'll create a null writable, null key. Oh gosh, if I could type, and that's going to equal to a null writable dot get, and we could probably make this final static. We're just going to use the same one over and over again. And then let's go ahead and create our value object. So this is going to be a text, and this is going to be out value. And we'll set this, we'll just initialize it to an empty text object. All right, so now we've created our out key and out value. Let's go ahead and define our reduce method. Actually, I'm going to rename my input argument. So we'll call this key. The value is actually an array, so it's values. It's an iterator on int writable, so there's more than one. We'll call our output collector outputs. And again, we're not going to implement report or actions, but we'll at least rename it there. All right, so the first thing we want to do is create a counter. So we're going to basically count the number of values for each key and emit that. So we'll initialize that at 0, and while values dot has next. All right, and we'll say we'll increment the counter plus equals values dot next dot get. Now I'm going to do it this way in case in the future we want to implement a combiner, because it could possibly, if you do a combiner, it's possible that the value comes back as not a 1. So we want to basically increment the sum or the actual value that's being pulled in the int writable. All right, next we need to output our key value. Actually, we need to create our new value. So let's do out value dot set. And we're going to take the key that already exists to string, right? And we're going to concatenate to that pipe, and then we'll add the new counter value. So the output will then be the category pipe section, which is in the key, pipe, and then the number of page views that are entries in the counter. All right. And so now we finally can collect our output, our key value pair. So output dot collect, and we're going to do null key and out value. And I believe we are done. Save this, and no errors in my reducer. Okay, we're ready to roll. So let's jar this code up and run it. We'll go into our Java perspective. We'll export to a jar. Sure. All right. All right. Let's do it. Hadoop jar, demo.jar. Alright, let's see, it's demo.myDriver is the class, and then we need to give it input. Weblog slash parse short, and we'll give it the output folder, weblog slash entries underscore Java, and let it rip. And alright, the job has been submitted to Hadoop, and it's running. Hopefully we'll get some response here shortly. There you go, the mapper's done. And waiting on the reducer now. 33%, so the data's been shuffled and sorted. It's done. Alright. So as it finished, let's go browse our name node and see if it's there. So refresh this, and the output should have gone to entries Java. And let's look at our file. And hey, what do you know? It worked. There you go. There's the category pipe section, and then the count of the entries, which looks like the same number from when we did it with Pentaho MapReduce. So if you made it this far, I congratulate you. This was quite a long journey to the dark side of Java MapReduce programming. I think our Pentaho MapReduce recording lasted only about 15 minutes. This one took at least 30. And to be honest, I spent a couple hours coding and debugging the example before recording. After viewing this demonstration, we think you'll agree with us that developing MapReduce programs with Pentaho will provide a quantum leap in your productivity. Thanks for watching, and thank you for your interest in Pentaho.